In this video, we'll have introduction to queue data structure. Queue is a logical data structure. It works on discipline FIFO, first in, first out. Like in daily life, we find various places we form queue, like people are standing in a queue to avail some services or for submitting their application, or cars are standing in a queue at a toll booth, or your application is in queue. Even our phone calls, sometimes if the lines are busy, we get a message that you are in queue, please wait. Or customer care, if you are calling, then we also get a message that you are in queue, our customer representatives are busy, please wait. So we find queue at various places. So queue is commonly used in various applications. In same way, in various algorithms, queue is used. So queue is one of the basic data structure. So here is an example of a queue showing people are standing in a queue, and this is like a counter. So they are waiting in a queue to get their turn to avail some services or do whatever the work they have. So this works on discipline FIFO, that is first in, first out. Queue will have two ends, like this end is called as front end and this is called as rear end. If a person wants to join a queue, then he should come and stand at the end of a queue, that is rear end. So I can call it as insert. So insertion is done at rear end. And if this person has finished his work at the counter, then he can go out from the queue. So this we can call it as a delete, and deletion is done from front end. So insertion is done from one end and deletion is done from another end. So both the ends are used here. Whereas if you remember in the stack, like this is a can, so insertion is done from this opening and the deletion is also done from same opening. If you have some balls in the can, this is the only end from where you insert, and from this end only you can delete. But here in queue, you insert at rear end and delete from front end. So let us look at ADT of queue, abstract data type of queue. Let us look at QADT. First of all, we will look at data. First of all, we need is space for storing elements or storing objects. Next, we need a front pointer that is useful for deleting the elements. It may be pointing upon or before the first element, but it is used for deletion of elements. The next thing we need is a rear pointer that is used for inserting the element. It may be pointing upon last element or after the last element, but it is used for insertion. So this is about data that we need: space, front pointer and rear pointer. Now let us look at the operations on a queue. First operation is enqueue. Enqueue means inserting an element in a queue. So insertion is done from rear end. Like if a person wants to stand in a queue, then he has to come and stand here at rear end. Then second operation is a dequeue. Dequeue means deleting an element. Deleting an element is done from front end. Means if a person has to leave a queue, then he should go out from here once his work has finished. Then the other simple function like is empty, checking whether queue is empty or not, and is full if the queue is full or not. Then if at all, if you want, you can write down other functions also, knowing what is the first element in the queue, knowing what is the last element in the queue. If at all, you can add them. And if you want, you can write more functions like displaying a queue or counting the number of elements in a queue. These type of operations are your choice as per your requirement. So this is the ADT of a queue. Now next, queue can be implemented using two physical data structures, that are array and linked list. So queue can be implemented using any of these two data structure, array as well as linked list. So we have to learn how to implement a queue using array, then how to implementing a queue using linked list. That's all in introduction. So the next video will learn how to implement a queue using array. Implementation of queue using array. We will learn these things. We will implement a queue using just one single pointer. Then I'll explain you what are the problems in that one, what are the drawbacks. Then I'll explain how we can implement it using two pointers, that are front and rear pointers. Then I'll explain what are the drawbacks of implementing queue using array even if you are using two pointers. So let us start with implementation of queue using single pointer. For implementing a queue using array, I have to take an array of a fixed size. So I have an array of size 7 here. Indices are from 0 to 6. And I need one pointer, so I have taken a pointer that is rare pointer. Initially there is nothing in the queue, so it is pointing on -1. So right now queue is empty because rare is equal to -1. -1 is not an index in array. Indices starts from 0 onwards. So it is standing before that location. That is before first location. So I don't have two pointers here. I have just one single pointer, that is rare. Let us see what happens when I try to insert and delete just using rare. Let us first insert few elements. If I want to insert any element in a queue, then the procedure is move rare to next location. So I'll just write R instead of writing complete word rare and insert an element. A new element is inserted. Just move rare and insert an element. Let me add a few more elements. Just increment rare to the next location and insert an element. Likewise, just move rare to a next location and insert an element. So this is how insertion can be done. So how much time it is taking for insertion? See, the steps are simple. Move rare to next location and write down the value there. So the time is constant. So insert operation is taking just constant time. I will fill few more values in this one. Now I want to delete the element from the queue. So which element can be deleted? So from the queue we can delete only this element, that is the very first element, because it is FIFO, first in first out. Which element came first? This element came first, so only that element can go out. So for deleting that element, I will just take out that element and assume that it is removed from the queue. So 5 is here, it's deleted. After deleting the element, this location is empty. So in array, we don't leave blank spaces or we will not have any empty spaces. I have to fill that space. So for filling that space, I must move all these elements. So shift all these elements on the left hand side. So 7 comes here, 15 and all these comes here and 2 will be coming here. So I should also move rare to a previous location. So after deletion, when this space got vacant, our actual queue is starting from this location. We should not have blank spaces in an array. If we have, then we have to check every time whether there is an element or it is blank. So we have to do some extra work, that is every time is it blank or element is there. So we want to avoid blank spaces whenever we are using array. So to occupy that blank space, all these elements should be shifted. And for shifting the elements, how much time it takes for deleting an element? Order of n. As many elements are there, you have to shift all of them. So delete operation take order of n time. So insertion takes order of 1 time, deletion take order of n time. So this is the drawback and we want to remove this drawback and we want to make delete operation should also take constant time. So let us see next method of implementation by using two pointers. Let us understand the drawback once again through an example. See, these people are standing in a queue and this person is providing some service. So he is handling a counter, this is a counter. And the people are coming and going in FIFO fashion, that is they are forming a queue. So if a new person comes, he will come and stand here. And whose turn is now? This person. So when he has finished his work, he will leave. Let us see what happens if this person is leaving the queue, his work has finished, so he is leaving the queue. If the person is going out from the queue means it is a delete. So let us see what happens. If this person goes out, so this is deleted, then this space is free. So this space should be occupied. So usually what happens if the people are in the queue, if a person goes out, all people will move one step forward. All will move. So this person will move here and he will come to his place and he will come to his place and this person takes his place. So they all will shift because this person has gone. This person is not there in the queue. So this place is free. So all will move. How many steps are taken when the one person has stepped out from the queue? How many steps are taken? N steps are taken. As many people are there in the queue. So the time for deletion is N. Yes, because N people are moving forward. So they are shifted. So instead of that, if this counter can be moved or this person can move, if this person just takes one step and move forward, then we don't have to shift all these people. This place is vacant, so he can move forward. So this is what the idea we will use for implementation of queue using 2 pointers in an array. One pointer we use for insertion and one pointer we use for deletion. So it means instead of shifting the elements, we will move the pointer. So let us see the implementation. For that, I have taken a queue here. I'll explain how this queue works. So here I have taken a fixed size array, and the size of an array is 7. And I have 2 pointers. Front, for that I have written just F, and rear I have written R. Initially they are at -1. So initially front and rear both are at -1. So it means there is nothing in the queue and queue is empty. Queue is empty. So right now you can see that both are at -1 and also both are equal. Front is equal to rear. Yes, queue is empty. Let us see how to insert elements. For inserting an element, I should move rear pointer to a next location and insert an element. So it's so simple for inserting an element. Now I will insert next one more element. So just increment rear pointer, move it to the next location and insert an element. So how much time it is taking for inserting an element? Just constant time it is taking. I'll insert few more elements. I have inserted few more elements. Rear is pointing on the last element, that is recently inserted element. First element is at index 0, but still front is pointing on -1. Now let us see how to delete. For deleting an element, first of all move front to a next location and take out that element. Delete that element. So easy. Just move front and take out the element. Let us delete one more element. Move front to the next location and delete the element. Oh, this is very easy. How much time it is taking? It is taking constant time. Just move front and delete the element. So simple. Yes, the idea here is same as the example of what I have explained you now, that counter is moving, the table is moving, people are standing in their own places. This counter is moving forward. And one more thing to observe, I am keeping front pointer before the first element, not upon the first element. Whereas rear is pointing upon the last element. Front is pointing before the first element. So logically, if you see the counter, that counter will not be upon the first person, right? It will be in front of the first person. So front is acting like a counter. So it is pointing before the first element. So now both NQ and DQ operation, that is insert and delete operation, are taking constant time. So our queue has become faster. So with the help of 2 pointers, it became faster. So both NQ and DQ operations are taking constant time. Now let us look at the condition. When do you say queue is empty or queue is full? Now let us look at the condition. When do you say queue is empty and when do you say queue is full? So I have few elements here. I will delete few more elements. I want to delete one more element. So the method is move front and make it point here and delete the element. I want to delete one more element. So the method is move front first and delete the element. That's all. Now there is nothing in the queue. Queue is empty. So what is the condition when queue is empty? Front and rear both are equal. So front is equals to rear is the condition for queue empty. Initially also when front and rear were pointing here at -1, they were equal. So whenever they are equal means queue is empty. So empty condition is if front is equals to rear. So right now it is empty, right? We have to see full condition. But before that I want to show you one thing. Just watch here. Suppose I am having already 2 elements, 10 and 12. And front was pointing before the first element, right? Now you may think that why not it is pointing upon first element. So let me do it. If it is pointing upon first element, let us say it is pointing from the beginning, it is pointing on first element only. Let us assume. Now I want to delete. So that element will be deleted. Then where front should go? It should go to the next element because this is the next element present there. There is no element present here now. So front should move. Okay, front has moved. Now is there any element available? Yes, there is an element available, right? But is the queue empty? No, it's not empty. Then what is the condition? Front is equals to rear. Front is equal to rear now. How it is not empty? So this is a problem. Okay, if we say that front is equals to rear is not an empty condition, then one more element is there. Okay, delete that also. So if I delete this element, then I should move front to the next location. Yes. Now what is the condition now? Front has become greater than rear. Now queue is empty. So if you say that front should point upon first element, then you have to write this as a queue empty condition. What is that? Front is greater than rear. So if you want, you can implement it like this, and you have to make front point upon the first element. But I prefer that front pointing before the first element is more comfortable, so I am following that method, because it gives a meaningful condition that front is equal to rear. Okay, it is empty. Now let us insert few more elements in the queue and see what is a full condition. I want to insert one more element. There is no space because queue is full. So how do you say queue is full? What is the condition? See, rear is pointing on 6 and the size is 7. So rear is equals to size minus 1 is a full condition. So here I write queue full condition. So queue full condition is rear is equals to size minus 1. So we have studied how to implement a queue using array and 2 pointers. So 2 pointers initially they are at -1, and we always use rear pointer for inserting, front pointer for deletion. Front pointer points before the first element, that location we keep it as empty. And when front and rear both they meet and they are at same place, then the queue is empty. If rear has reached the end of an array, then queue is full. Now we will look at implementation, that is program code we will look at. For implementing a queue using array, we require following things, that is a fixed size array, and the size also we should know what is the size of an array or a queue. Then also we need 2 pointers that are front and rear pointer. So all these things we can combine them together under a structure because all these are related to a queue. So let me define a structure for a queue. Structure queue. So what are the members I need? I need the size. What is the size of a queue? That is size of an array. Then I need front pointer to point upon first element and rear pointer to point upon last element. This is used for insertion and this is used for deletion, front for deletion. Then also I need an array space. So what size it should be? It can be known only at runtime. When really program is running, we can decide the size and create an array dynamically from heap. So for creating array dynamically, I should take a pointer. So I will not declare an array, but I will just take a pointer q for an array. So this I will be creating it dynamically. Now let us see how to create the variable of that type structure and how to initialize it. So I will write on the program code and show you this code. We will be using it wherever required whenever we are using a queue. Let us assume that this is a main function, right? Inside main function, I am creating a variable of type that structure queue. This queue is an object of that type structure. So once I create this object queue or variable of type queue, I'll get following members. First one is size and second one is front pointer and the next is rear pointer and q is a pointer to an array. So I am calling them as pointer. These are not actually pointers. These are index pointers, right? So index pointers, those are not address pointers, but they are pointing on the element. So we are calling them as pointers. Don't confuse them with address pointers. So a variable is created, then we have to initialize all these. So first of all, I will find out what is the size. So I will take the size from the keyboard. I will give a message, enter the size of a queue and then take the size. So here a message is enter the size, then scanf, I have to take the size. So size is what? Q dot size I have to say. Q is the size. So Q dot size. Q dot size. So with this, whatever the size is given, that size will be filled here. Suppose the size is 7. So 7 is the size. Then based on that size, I should create an array of a size 7 and fix it to with this pointer Q. So I should create this array. I should create that array. So for creating that array, I should say q dot q. So q is a variable name and it is having member q as a pointer of type integer array. This is an address pointer. Then to this, I should dynamically allocate the memory from heap and assign it. So for dynamically memory allocation, we use malloc function or else we can use new. So malloc will create an array and to that q will be pointing, right? So instead of writing lengthy code, I was preferring writing new, and while typing the program, I am using malloc function. Now the last thing, I have to initialize front and rear. Initially both are -1, so I have to set this as -1 and this also as -1. So say q dot front as well as q dot rear both assign -1. So we can initialize them together in a single statement. So these are the steps required for initializing a queue. Now let us look at functions, operations on a queue. That is, we look at NQ and DQ operation. So I will write down the functions for NQ and DQ. So NQ function. NQ function is taking a value that we want to insert in a queue and also in which queue you want to insert. So it is taking queue as called by address or called by reference. So if suppose this is the object created in main function or some other function, wherever it is, we want to insert in that queue, then this queue is a pointer to this one, pointer to that particular object. Now let us write the function. For insertion, first of all, we should know is there any space or not. If there is no space, we cannot insert. If there is no space, means queue is full. So first check whether queue is full. So I'll write on the condition for queue full. If this is the case, then queue is full. I cannot insert any element. So here simply I'll give a message that queue is full or queue overflow. Queue is full. If it is not full, then we can insert the element. So else, how to insert the element? So for inserting an element, we should move rear pointer one step and then insert the element. That's it. Step is simple. Move rear and insert the element. So this rear I should move, this rear. So queue's rear plus plus. So queue's rear is moved. So queue's rear plus plus. So rear becomes now 0, means it's pointing here. So here in this data structure, if you see, it is 0. So it means it's pointing on index 0, right? Then at queue's 0 position, means queue's rear position, I should insert the value. So queue's queue. So value 12, whatever the value you are inserting, it will be inserted there. But we are visualizing it like this. This is how it happens inside mem. So that's all. End of the function, end of else part and end of NQ. If you look at the steps are simple steps. Either say print it is full or else 2 steps. So the time is constant. So from the code also you can see that the time is constant. Now next let us look at DQ operation, that is a delete operation. Now delete operation. Function name is DQ, that is for deletion, and this is having a pointer to this variable or this object. So when you call this function, you have to pass that as parameter, and this is called by address or reference. Now for deleting, I have taken some variable x and it is initialized to -1. Now let us write down the steps. Before deletion, what I have to do? Before deletion, check whether there are some elements or not. If there are no elements, we cannot delete. So when there are no elements, means it is empty. So what is the condition for empty? If front and rear are equal, we cannot delete them. So if front and rear are equal, it is empty. So first I should write on the condition that if front and rear are equal, so whose front and rear? Queues. So I can access this using arrow operator. Queues front and queues rear if they are equal. So say if queues front is equal to queues rear, then I should just display a message that queue is full. Then here I just display a message that queue is empty. So printf queue is empty. So queue is empty. If front and rear are equal, queue is empty. I cannot delete any element. Else, how to delete an element? So for deleting an element, just move front pointer to a next location and take out the element. That's all. So how to move front? This front I have to move, so that is queue's front plus plus first of all. So queue's front is moved. Queue's front is moved. Then from that place I should take out the elements. So I can take out that element in variable x. So inside x I am taking out the value from queue's queue, that is queue's queue, that is array. From that array, from which place I am taking out the value? So queue's front I am taking out the value. It is taken in x. Now finally return x. So outside else I am writing return x. So the value that is deleted is return. What happens if the queue was empty? So that x will have -1 and nothing is assigned to x. So it will return -1. So if this function is returning -1, means queue is empty. There are no elements in a queue. So that's all. This is a DQ function. And if you look at the function, the steps are very simple. Condition is checked and the printing is done. Otherwise, just 2 simple steps. So the time taken by DQ is constant. So from the code also you can see that it is constant. In this video, we'll look at a C language program for implementation of queue using two pointers. So I will give the project name as queue using array, and the language is C language. Create a project. Now project is ready. First of all, for queue implementation, we need to define a structure that is queue. Inside this, we need to mention the data members, that is size of a queue, and then we need a pointer that is front, and we need a pointer that is rear, and also we need some space for storing the set of elements. So I'll take a pointer for that one. Now let us create a queue object inside the main function. So here I will say struct queue and variable queue. Now first of all, queue should be initialized. For initialization of a queue, I will write on a function called create. So let us write a function create, which will take a structure of type queue as a pointer, and it will modify the queue. And also it should know what should be the size of a queue. So let us take one variable, that is size. Then it is taking two parameters, that is for initialization, it needs size. So here inside create function, first of all, for a queue, we will initialize the size as size. Then we will initialize front pointer, and also we will initialize rear pointer to -1. Then I should create an array inside heap of size given size. So queues queue, here I will assign a array. Using malloc function, I will create an array of given size. So that should be queue's size, whatever the size of a queue is, into size of integer. So that's all. This will create a queue, that is initialize a queue. Now from the main function, I should first create a queue, and I should pass the address of this queue, and size I want, let us say size 5. So creation process is over. Now I should implement the functions for enqueue, dequeue, and display. So first function is enqueue. For enqueue, first of all, we should check whether the queue is empty. So for that, the condition is if rear is equal to queue's size -1, then queue is full. So we can simply say we cannot insert and queue is full. Otherwise, we can insert an element. So else we can insert an element. So for inserting an element, first rear is incremented, rear plus plus, then queues, queue caps rear is assigned with x. And in enqueue, it should take one more parameter, that is structure no queue type. That is, it should take a pointer queue. I missed this one. So it's taking a queue as a parameter as well as the element to be inserted. Now let us write a function for dequeue. It should take a structure queue, that is pointer queue. Now here for deletion, I need some variable, so I will initialize it to -1 x. Then first check if it is empty. So if queue's front is equals to queue's rear, then we will print we cannot delete it. Queue is empty. And /n. Otherwise, we can delete the element. So for deletion, first of all, we should move the front pointer. So front plus plus. Then in x, we will take the value from the array wherever front is pointing. That is queue's front. That's it. So the value is deleted. Then return the deleted element. Return x. Now we should have a function for display. So here I will write display function, and the display function should take a structure queue. Then using a for loop, we can display all the elements. So for I takes values from front plus 1. So it is queue's front plus 1. Queue's front plus 1. And I is less than equal to queue's rear, and every time I plus plus, and print the values. Printf %d some space and queue's queue of I. So from front to rear, it will display all the elements. And here I should declare a variable I. And at the end, after displaying all the elements, I should give a line gap. So printf/n. That's all. So I have implemented all the functions. Now inside the main function, let us insert few elements. So I will call the functions enqueue, and in this queue, I will first insert 10. Then I will insert 20. Then I will insert 30. So I have inserted 3 elements. Let us call display function display queue. It's not taking by pointer, it's not by address. Let us run this. Yes, the queue contains 10, 20 and 30. And that's it. This is sufficient. And even I will call delete function here, %d. I will display the deleted value and call dq and send the address of queue. See, 10 is deleted. That's it. You can try all other operations. You can try them and you can check whether it is displaying queue is full or empty. All those things you try them. That's all. Queue program for implementation of queue using array. In this video, we look at a demonstration for C++ class for queue using array. So queue using array in C++. I'll call this project name as queue CPP, and the language type I will select it as C++. Create the project. Project is ready. Yeah. So let us write down the program now. Let us write a class. So first of all, I will say using namespace std so that I can use scene and cout wherever required. Now I will write a class for queue. As it is a class, I should have private data members. So in private data members, I should have front pointer and a rear pointer and the size of a queue. And also I need a pointer for queue for storing the elements. So for an array, I have taken a pointer. Then public functions I should have. So first of all, I should have a constructor. So for that, I will take a non-parameterized constructor, which will initialize front assign, rear assign -1. And next thing, let us say default size is 10. So I will take size 10. Then queue should be initialized. So array queue is created with new int of size, whatever the size is. So I have written everything in a single line so that you can see the complete class at once. Next is a parameterized constructor which should take the size. So let us take a parameter size, and from here I will copy everything and I will modify them accordingly. So front equal to rear equals to -1, then size is not 10 now. The size is size only. As this is ambiguity, so I should say this size. And here also, when creating an array, I should say this size. So if you have already watched this C++ class for stack, so you know that how I am writing everything in a single line. Then I should have a function for enqueue. This is a member function for enqueue which will take an element. Then I should have a function for dq which will delete an element. Then I should have a function display for displaying a queue. That's all the members I have defined. Now I will implement these methods outside the class. If you want more functions, like you want to know the first element or the last element, you can add more function, is empty, is full. So as you like, you can add more functions to this data structure queue. But make sure that is working on FIFO. Then outside the class, I will implement other functions. So first is enqueue. So first of all, class name, then the scope resolution, then enqueue, which takes a parameter x. Now already you know the procedure. What I have to do, I have to check for queue full or not. If rear is equals to size -1, then printf queue full. Otherwise, I should move rear pointer, rear plus plus, then queue of rear assigned with the value that I want to insert. This is enqueue. Then for DQ, first is the class name, scope resolution, then function name is DQ. And before deletion, I should check if front is equals to rear. If so, then queue is empty. So I should give a message queue is empty and slash and stop it. Otherwise, I can delete an element. So for that, I need a temporary variable. So integer x assign -1 as we were doing it. Then here, for deletion, I should say x assign q of front +1. I should take the element first, then front ++. I can increment front. Then afterwards, return an element x. Then display function, class name, and the function name is display. And I have to use a loop for displaying this. For integer I assign front +1, and as long as I is less than equal to rear and I++, then every time print the element. So %d with a space, I should print an element from q of I. At the end, I should give a new line for better output. So I have given a new line. That's all. The complete class is ready. You can code this class by yourself. Now here inside the main function, I will create a queue object q of size 5. Then q.enqueue, I will insert some element like say 10. Then I'll copy this and use the same code for inserting more elements. Then I will say q.display. This is 20 and this is 30. Let us run this. Yes, it is displaying 10, 20, 30. 3 elements are displayed. I guess this is sufficient. So you can write down a class and you can test all the functions by yourself. I have tested only enqueue and display function. And one more thing, this class can be converted using a template. You can make it as a generic class. Already I have shown you quite a few times how to convert a class into a generic class. Our previous topic was implementation of queue using 2 pointers. We have used front and rear. There are some drawbacks in that method. So we'll learn what are those drawbacks, and also we'll find some solutions. So there are two type of solutions, that is resetting pointers and circular queue. So in this video, we'll discuss what are the drawbacks and their solutions. How to remove those drawbacks. Let us look at drawback. Here is a queue of size 7. I have an array of size 7 and already it is filled with some elements. Rear is pointing at 6 index, that is size -1. So I can say that queue is full. Yes, there is no space for inserting any more element. And this is the first element, so front is pointing just before that element. Now what is the drawback? I want to insert a new element in the queue. So enqueue operation already we saw. If I try to insert rear is equals to size -1, I get a message queue is full. I cannot insert the element. But if you see, already few elements are deleted from the queue, so these spaces are free, these are vacant. I cannot use them because the insertion is done from rear end and there is no space at rear end. This is at the front end. So these spaces we cannot utilize. So the first point is we cannot reuse the spaces of deleted element. Let me delete few more elements and show you. If I am deleting this one and this one also and this one also, so front will be pointing. Now so many elements are deleted, there is only one element in the queue. Now still I want to insert enqueue. So for enqueue, condition is checked. Rear is equals to size -1, that is 7 -1, here 6. Queue is full. I cannot insert an element. Though there is a lot of space free. So it means, second point, every location can be used only once. I cannot reuse them. Then third one, I will delete this element also. The front will point here. So front and rear are pointing at same place. So queue is empty. Front is equals to rear, queue is empty. Can I insert any element? No, queue is full because rear is equals to size -1. Queue is full. Rear is at last location. Third point is a situation where queue is empty also, full also. So these are the 3 points we saw, that we cannot reuse the spaces of deleted elements. Second point, we can use each space only one time. That is a similar point only. The third thing is, there may be a situation even queue is full as well as empty. Array spaces can be used only once. We want to reuse the space. How to reuse the space? First solution is resetting pointers. First solution. Solution is resetting pointers. So what I should do? At any time, if a queue is becoming empty, at any place, bring front and rear pointer at the beginning, that is reinitialize them to -1 so that they can again start from the beginning. So in this way we can reuse those places. Let me show you a little bit by inserting few elements. Suppose I have inserted 3 elements. So I have 3 elements. Now I want to delete 2 elements. Now after deleting 2 elements, front is here. Now I want to delete one more element. When we delete one more element, front will move to the next location and this element is gone, and both front and rear are at same place. So it is empty, so queue became empty. So reset them and bring front and rear at -1. This is what we will do in resetting pointer. Not just at the end, anywhere in between. Whenever front and rear are becoming equal, means queue becomes empty, bring them quickly on -1 so that we can reuse the places. But this method doesn't guarantee that these spaces will be reused definitely. If a queue is not becoming empty at any time, then we cannot reset them. And we cannot even insert more elements. So this method doesn't guarantee reusing of spaces. Then we want second solution. So let us look at circular queue. Now for circular queue, I will discuss the basic idea by taking the example. See, the problem that we are getting here is because we are moving front pointer. Instead of shifting the elements, we are moving front pointer. So if you remember the example I took, the people are standing in the queue. This person is handling a counter. So I have not shown that box. So what we did is, if this person is leaving the queue, instead of shifting all these people forward, what we thought, let us move this person ahead. Okay. So in this way, only one step will be taken and the deletion of a person will be done just in constant time. Only one step will be taken. Now if one more person is going out, then again he will move just one step. This person will move. This person is moving. So in this way, what is happening is, so in this method, we are getting a lot of free space here. And this space is full. There is no space for a new person. So if a new person wants to join the queue, he cannot join. There is no space here. Now the idea. We will ask this person to come and stand here. This is the back side of the counter. If this is the counter, this person is the front person, counter at the back side. So nobody will stand at the back. Now, if this person says that once I finish with all these people, when I have finished with the last person, again I will come and stand here. Again I will start from this place. If you say that I will be using this space circularly, then people can start forming a queue here also. Yes, that's what the idea is. If the person who is serving, who is handling a counter, he can come back again here. So he can move circularly. So same thing we want to implement here also. Who are inserting and deleting front and rear? Let this front and rear move circularly. Once they have reached 6, let them come back again on 0. Then again continue like this. So this is the idea of circular queue. I will take few elements and show you how it is done. Now let us learn about circular queue from the beginning. See, initially front and rear will be at 0. We will not start from -1 now. We will start from 0. So you'll understand why we are starting from 0. Next, using rear we will insert, using front we will delete. So I will insert some element. I will insert one element 10. So rear will move ahead and insert a value 10. So the procedure is same. Yes. What about this location? That location should be left empty. We will not use that location. Wherever front is pointing, that location must be left empty. Let me fill all the elements until this front reaches here. I will fill all the elements. Now queue is full. I have filled all the elements. Rear is at size -1 and front is still at 0. So queue is full. Let me delete few elements. So first element I will delete. So for that, move front to the next location and remove the element. So that element is deleted. I want to delete one more element. So move front to the next location and delete the element. So this element is gone. Now I have free spaces. I want to insert. Can I insert? Yes. Bring rear at 0 and insert the element here. So you can see that a new element is inserted at the back side of front pointer. And you can see that when rear was 6, it became 0. Now I want to insert one more element. This time rear will move in a normal fashion. Rear plus plus, just move one step. Rear will come here and insert the element. So yes, the element is inserted. Can I insert one more element? No. There is a free space. Can't I use? Don't use that space. Wherever front is pointing, that space must be left empty. What happens if I want to use that space? So if you bring rear there, then rear and front both are equal. Rear and front both are equal. Equal means we know the condition. When they are at same place, queue is empty. Let me show you. I will insert one more element, 25. Now front is equal to rear. Is it full or empty? See, actually it is empty condition. So that is the reason we will not use that place wherever front is pointing. So rear is at this place. So if the size of an array is 7, how many elements I have stored? Only 6 elements I have stored. We cannot use all 7 places. Then, if I am deleting using front, then I will be deleting all the elements. Then again, front also moves like this. So we will implement circular queue over an array by moving front and rear circularly. So array is not circular here. Front and rear are moving circularly. So let me draw a diagram how we usually represent it. I'll show you. So this is how we represent a circular queue. We show array as circular, as array is not circular. Front and rear will move circular. Then how to move front and rear circularly? We want a mechanism such that they automatically move circularly. So what we want, let me show you. When front is on 2, if I say next, it should go on 3, then next means it should go on 4, next means it should go on 5, next means it should go on 6, next means it should come on 0. So I'll be moving next, but after 6, it should come on 0. So circular behavior or the circular values like 0, 1, 2, 3, 4, 5, 6, then again 0 we want. This can be obtained using mod operation. So how we can take the help of mod operation? I will show you. Let us see how mod operation can be used for obtaining circular values. I'll explain it with the help of just rear pointer. Same thing applies on front pointer also. So let us start. Initially rear is 0. So what it gives? 0 plus 1 mod size. Size is 7 as per our example. So the result of this one is 1 mod size. 1 mod size. Mod means remainder. It means when 1 is divided by 7. So it cannot divide. So 7 zeros, remainder is 1. So that number, when it is smaller than 7, that same thing is a remainder. So this is 1. So that 1 is the new value of rear. The next is 1 plus 1 mod 7. So this is 2 mod 7. So the result is 2 only. So that is the new value of rear. Rear is modified. So rear assigned rear plus 1 mod size. So rear is modified. Rear is 2 now. So 2 plus 1 mod size 7. So 2 plus 1 3. So this is 3. It gives 6. From 6 if we say next 6 plus 1 mod size 7 mod 7. 7 mod 7. If 7 mod 7 means 7 ones 7, remainder is 0. So remainder is 0. So again rear is back on 0. So this statement will give us circular values. From 0 it has started, again reached at 0. So by using mod operator, we will be moving front and rear. So now the previous example what we saw in a queue using array, we will modify NQ and DQ operation and we will modify the movement of front and rear pointer in that one. It becomes a circular queue and it guarantees always the spaces will be reused. So this is the best method of implementing a queue using array. It must be circular. Let us see NQ and DQ functions. I will write the function and explain it. Let us see NQ function, how it works for inserting an element. NQ function takes a queue as a pointer. It's the pointer to a same structure which we have already seen and it is taking a value that to be inserted. Then before insertion, I should check whether there is any space or not. Can I insert any value or not? If it is full, I cannot insert the element. So I should check for the condition. So I should check for queue full condition. So what is queue full condition? So for explaining queue full condition, I have taken two examples here. These are the two examples. So let us look at the second example. Here you can see that queue is full. The place where front is pointing is left empty and all other places are filled and rear is here. Now it is full. And this one, front is pointing here, that place is left empty and this portion is full and even this portion is full. So rear is standing just at the back of front. Next location to rear is front only. So what about this? If you see circularly, then what is the next place of rear? After 6 comes 0. So this is also the same situation. So next place of rear is front, then queue is full. So here I am checking that same condition. Rear plus 1 mod size. Rear plus 1 mod size. As because both are in this structure, so I have to write queue's rear and queue's size. Rear plus 1 mod size, if it is equal to front. So I'm not modifying it, just calculating. That is next place is front. If so, then queue is full. Otherwise, move rear. How to move rear? Rear is modified by rear plus 1 mod size. Then at that same place, queue's rear value is written. So that's it. This is NQ for circular queue using array. Next we will see DQ. Let us look at DQ operation. DQ function is taking a queue of same type structure which we have already seen earlier, that is queue structure. Then I have taken one variable in which we will be deleting the value. Which condition I should check for deletion? Queue is empty. So what is the queue empty condition? Same, front is equals to rear. So initially you saw that when both front and rear were at 0, queue was empty. Front is equals to rear, queue is empty. Here the message is queue is empty. If it is not empty, then I can delete the element. So for deletion, which pointer we use? Front pointer. So I should move front to the next location. And that movement should be circular. So this is the code for circular movement of front. I'll read out. Front is modified with front plus 1 mod size. So Q is coming everywhere because all these are members of a structure. Q's front is equals to Q's front plus 1 mod Q's size. Then from that place, Q's front place, that is Q's front, take the value and then return the value. So that's all about circular queue. We have seen NQ operation as well as DQ operation. And one more thing, both the functions are having just simple statements, so the time for both these functions is constant. So the conclusion is the best method for implementing a queue using array, you should make it circular, then only you can reuse the spaces. Otherwise, the spaces can be useful only once. We cannot reuse them. In this video, we'll look at a circular queue using array. So already we have implemented a queue using array. So let us look at the structure. Structure remains same, the size and the front and the rear pointer. And the queue is an array where the elements are stored. Then let us look at create function. The size is same only. But front and rear should not be at -1. They should be initially at 0. Then creation of an array of size, given size. Then NQ operation. In NQ operation, using mod operation, I will write on the condition for queue full. Queue full condition is if rear plus 1 mod size, that is mod size, queue's size, and this should be inside bracket. Yes. If rear plus 1 mod size is equals to queue's front, then queue is full. And if queue is not full, then rear should be incremented by queue's rear plus 1. Then this should be mod with queue's size. Mod queue's size. That's it. And queue's rear assign value x. Then while DQ, the condition is same. When front is equals to rear, queue is empty. Otherwise, front should be incremented. And again, incrementing front is using mod operation. That is queue's front plus 1 mod queue's size. It should be mod with size. This display function, I should write it using while loop. I will actually write using do while loop. So this I should start from front plus 1, that is queue's front plus 1. I should start from there. And using do while, every time after printing an element, I should increment using I plus 1 mod size. Mod size. And while I is not equal to, I should display the last element also. So I should say queues rare plus 1 mod size. Mod queues size. So it should go up to last element and it should display the last element also, and then it should stop. Let us run this. Yes, it's working perfectly. Now let me insert few more elements. Here I will insert few more elements, that is 40, 50 and 60. Let us run this. See, I got the message as queue full 2 times because in an array of size, queue of size 5, I can insert only 4 elements. So it's able to insert 10, 20, 30, 40 only. 50, 60 are not inserted. So the elements in the queue are 10, 20, 30 and 40. And when I delete this dequeue, 10th element is deleted. So that's all with this circular queue implementation using array. In this video, we'll learn about implementation of queue using linked list. We are already aware of linked list. So just we have to learn how to implement queue. Queue is a logical data structure, so we have to insert and delete an element in FIFO fashion. So for implementing it using linked list, already I have taken an example of linked list. Front is a pointer pointing upon first node and rear is a pointer pointing upon last node. So for insertion, rear pointer will be used, so elements will be inserted on this side, and for deletion, front pointer will be used, so the elements will be deleted from this side. So this end insertion and this end deletion. Usually on a linked list we'll have only one pointer, that is upon first node. Then why do I have one more pointer, that is rear here? Reason, this rear pointer will help me insert a new node in constant time. And always rear will be pointing upon last node. So right now in the queue, the first element is 8 and the last element is 4. We have to learn how to insert and how to delete, means how to enqueue and how to dequeue. But before that, let us look at few important conditions. First thing is, initially when the queue is empty, how front and rear will be. When initially queue is empty, both front and rear will be null. So if any one of them is null, let us say front is null means queue is empty, there are no nodes. So what is the condition for empty if front is equals to null? So I'll write on the condition here for empty condition. If front is equals to null, queue is empty. Now second thing, when I am creating the very first node, then what all I have to do? See, let us take a new node with the pointer t and insert some value. This is null. This is the first node created. Now when I know that this is the first node, how I can know this is the first node? Because front is null. Front is null means queue is right now empty. So this is the very first node. So I should make both front as well as rear point on this node. So this is the special case that I have to take care. When a first node is inserted, both front and rear should point on this one. Then the third thing, what is the full condition? So as it is implemented using linked list, unless you impose some size, there is no limit here. You can go on adding nodes. So there is no fixed size. But when the heap is full, when you are unable to create any node, then we can say queue is full. So I will write on the full condition here. So here create a new node. If a node is not created, then queue is full. Actually heap is full, so queue is full. Now let me write down enqueue function, that is insert function, and show you. Here I have a enqueue function. Already I have written the function. Let us study this function. Enqueue function which takes parameter x, the value to be inserted. Now where is front and rear? Assume these are globally accessible. Then for insertion, what is the first condition I have to check? Whether queue is full. So how to know queue is full? So directly I am creating a new node here. Then after that, if t is null means the queue is full. So the condition that we have already seen here. Same thing I have written here. It is full. Else, if it is not full. If it is not full, then suppose the node is created. Example, if a node is created with t, then here I should set the data and also set the next pointer as null for this new node. So I will set the data and also set the pointer as null. Then after that, I said that there is a special case if this is the first node. Check if it is a first node. How do you say it is a first node? If front is null. So here, if front is equals to null, means if it is the very first node, then make front and rear both point on T. So both front and rear should point on this node, front and rear. So if it is the first node or this is the only node now in the queue, then both front and rear will point on that same. If already nodes are there, else already nodes are there, then these are the steps. So let us see how to insert a new node after that rear. We already know about it, but just I am showing it again. If a node is created like this, T, right, and the value is inserted and this is set as null, so these two lines are over. Now else part, rears next assign T, this line, rears next assign T. So rears next, this should point on T. Then move rear to T. So this rear pointer should be moved on to the new node that is inserted at the end. So again, rear is at the last node. So whenever a new node is inserted, we will try to move rear upon that new node. So we make sure that rear is always pointing about last node so that we can finish insertion in just two steps, these two steps. So that's all about in queue. How much time it is taking? Because of the help of rear pointer, this procedure is very simple. Otherwise, if you remember, inserting a new node at the end of a linked list means we have to traverse through this linked list and then we can insert a new node. Unless we reach the last node, we cannot insert a new node. So because of rear, that time is saved. All the statements in this procedure are simple, just conditional statement, printf, or setting data, next conditional statement. There is no loop. If loop is there means the time may be n. But there is no loop, so statements are simple, so it is constant. So this is about enqueue. Next we will look at dequeue. Now let us look at dequeue operation. Dequeue operation will delete an element and return that element. So for deleting an element, I have taken a variable x that is initialized to -1. I have a pointer also here for temporary usage. Then before deletion, I should check whether there are any nodes in the queue or not. If there are no nodes, we cannot delete. No nodes means it is empty. So what is the empty condition? Already we have seen that condition. So here I am checking that condition. If front is equals to null, then queue is empty. I cannot delete it. Otherwise, else I can delete it. So which node should be deleted? Front node. How to delete this front node? For deleting first node, we know the procedure. We should have a temporary pointer P pointing on the first node. So P is pointing on front node. Then we should move front and make it point on next node. So front should move on to next node. This is step front assign fronts next. Then take out the data in variable x. This data is taken out in x. Then free P, so this node is deleted. Then after end of else, return x. So whatever the value was deleted, that will be returned. If suppose Q was empty, then it will return -1. So -1 is returned means there is no value or the Q was empty. So this is simple deleting first node. And deleting first node, we know well that it takes constant time. So yes, this procedure is taking constant time. Now the other functions, if you want to write, like displaying a linked list or knowing the first value, knowing the last value, you can write down. So while writing the program, I may be adding those functions. So that's all about queue. So we have seen two implementations of queue, that is queue using array and the next is queue using linked list. In this video, let us look at implementation of a queue using linked list. So I'll create a new project, that is queue using linked list LL, and the language is C language. Now create a project. Project is ready. Now for implementation of queue using linked list, I should use nodes of a linked list. So for that, I will define a structure that is node. So here the node is ready. Then I should have two pointers, that is front and rear. So I will declare them here itself globally. Front is initially null as well as rear is also initially null. So two pointers initialized. Then I don't have to create a linked list. Directly front and rear are initially null. No further initialization is required. Now I should have the functions like enqueue, dequeue and display. Three functions I will write down. First function enqueue. which takes the value to be inserted. Now for inserting, I should make sure that there is enough space inside heap. So first of all, I should create a node using temporary pointer t. So I will write on the code for node creation using malloc function. And when we use malloc function, make sure that a library is included, that is stdlib. Node is created. Then if node is not created, means if it is equal to null, then queue is full, we cannot insert any element. So we can say printf queue is full. Else we can insert an element. So I'll give a new line. Else we can insert an element. Then for inserting an element, already node is created, so I should set the data of that node as x, the value that we want to insert. And also I should make t is next as null, because this is going to be a last node definitely in a queue. Then first thing I should check that if front is equals to null. If front is equals to null means this is the first node. Then front and rear both should point on that new node t. Otherwise this is not the first node. Then rear pointer's next pointer should point on this new node t, and rear should be brought upon this new node t. So this is what I have explained you. So the same thing I have written here. Then let us write a dequeue function. Dequeue function will return a element that is deleted. So for that I will take a variable that is initialized with -1. Then for deletion I need a temporary pointer, so I will take a pointer t. Then before deletion I should check that if front is equals to null. If it is so, then queue is empty. I should give a message that queue is empty, and also /n so that I get a line gap. Else queue is not empty, I can delete an element. So I should delete first element. So x should be assigned with front's data. Then t should be pointing upon front so that we can delete a node. Then front pointer should be moved on to next node. Then we should free that pointer t. And at the end I should return x. That's all. This is dequeue. Then for display I should write a function display. For displaying I should scan through a linked list. So for that I will take a temporary pointer p, and while p is not equal to null, while p I can say simply, I should display all the elements. Printf, I should display the data of a node, that is p's data, and then p should be moved to a next pointer. And at the end I should give a line gap. So for that I will say /n. Now everything is ready. I have all three functions, that is enqueue, dequeue and display function. Now inside the main function I don't have to create any variables for queue. Directly I can start using the function. So first of all I will call enqueue and I will insert value 10, and I'll insert more elements by, I'll copy paste this. So I'll insert few elements, 20, then 30, then 40, then 50. Then after this I will call a function that is display, which will display all the elements in a linked list. Then on the top I must include a header file, that is #include stdlib.h. So back to the main function. Now let us run this one. Yes, it is displaying all the elements 10, 20, 30, 40, 50. See here in display this p should start from front, so I have assigned it just now. Then let us call dequeue also and directly display its result. So here I will call dequeue function. Let us run this. Yes, dequeue is deleting the first element 10. So that's all. This is the implementation of queue using linked list. So you can practice this program. Our next topic is double-ended queue. DEQ. So we read it as DEQ, not DQ. Double-ended queue. It doesn't strictly follow FIFO. It all depends on you. If you want, you can use it as a FIFO. It can be implemented using array or it can be implemented using linked list. So I have taken an example of array. Let us understand what is it. See, if we implement a queue using array, then we need two pointers, front and rear. Similarly, in the linked list, we need two pointers, front and rear. Rear is used for insertion. Front is used for deletion. But in DEQ, you can use both the pointers for both the operations, insertion as well as deletion. So with rear pointer, we can insert as well as delete. And with front pointer, we can insert as well as delete. So I'll prepare a table and show you here. See, from this table, you can understand in a queue, front is used for deletion, rear is used for insertion. Using front, we cannot insert, using rear, we cannot delete. But when we say DEQ, double-ended queue, front is used for both insertion as well as deletion, and the rear is also used for both insertion as well as deletion. How it is possible, I will demonstrate by inserting and deleting few elements. I want to insert, so I should say from which side I want to insert. Right now queue is empty and front is at -1. So I can insert from rear side. So insert from rear. If I insert from rear, then increment rear pointer and insert a value. Then again I want to insert using rear. So move rear pointer and insert the value. I will insert few values. So using rear, I have inserted few values. So using rear, insertion is done. Now using rear, I want to delete. So okay, take out this value and decrement rear pointer. It's possible to delete using rear pointer also, but it is not FIFO. As I said, we are not strictly following FIFO in the DEQ. Let me delete one more value using rear. So just take out this value and decrement rear. So that's how deletion is done. So from rear end, I have shown you both insertion as well as deletion. Let us insert from front. There is no space here to insert, so I cannot insert from front. Can I delete? Yes, I can delete. So how to delete using front? So this is normal method, move front pointer and delete a value. Delete one more, so move front pointer and delete a value. So this is a regular method of deletion. Now I want to insert using front. So okay, insert the value here at front pointer and move front, that is decrement front. So move it back. I want to insert one more. So insert value and move front by decrementing it. So it is moved back. Now can I insert any more? No, front is at -1. So I cannot insert any more now. So that's how we can insert using front as well as delete using front. Insert using rear as well as delete using rear. So both are allowed from both the sides. Though not FIFO, but if in your application, if you want, you can use it. Like Java supports a DQ type of data structure. It's there in Java. So it allows insertion from both the ends. Then there are some variations in DEQ. So I will prepare a table and show you. Yeah, here I have written there are two types of restricted DQ. One is input restricted DQ. So in a DQ, insertion and deletion is allowed by using both the pointers, but here input operation is restricted. So who actually perform input operation? Rear. So insertion is allowed only using rear, front cannot insert. But deletion both can do. So input means insert, insert is restricted. The next one is output restricted DQ, means deletion is restricted. So whose job is to delete? Front's job. So only who can delete? Front can delete, but rear cannot delete. What about insertion? Both can perform insertion. So this is a variant. If you want, you can use this type of data structure also. So input restricted DQ and output restricted DQ. Now writing the program using array as well as linked list. So I don't have to show how it works on linked list. You can understand that. So it's a student exercise to write a program for implementing double-ended queue. So 4 operations you have to write, that is insert from front and delete from front, insert from rear and delete from rear. So implement this one. Topic is priority queues. There are 2 methods of implementing priority queues depending on the situations. So we'll study them. One is a limited set of priorities. I am calling it as limited set of priorities are there. Means already priorities are fixed. The next is element priority. So the element itself will have its own priority. So let us see these two methods one by one. So let us look at first method. Let us look at first method. See, this method is useful mostly in operating system. Some operating system allows priority based scheduling, like in Java, JVM supports multi-threading, so it's allow priorities upon threads. So you can set the priorities for a thread. And Java supports priorities from 1 to 10. So to 10 different priorities a thread can have. So higher priority threads will execute first. That same thing is implemented using limited set of priorities. Like in Java, 10 priorities are there. So here in my example, I have taken 3 priorities. Now these are the elements. So instead of numbers, I have taken alphabets, and each element is having its own priority. So priorities are numeric values. That's why I have taken elements as alphabets. So this is the priority. Now 1 means highest priority, and 2 is little less than that, and 3 is least priority. You can set it other way also. 3 means highest priority and 1 means lowest priority. Like in Java, 10 is highest priority, 1 is lowest priority. But here in my example, I am saying smaller the number, higher the priority, or larger the number, smaller the priority. This is what I am saying. For implementing priority queue, as there are 3 priorities only in the system, so I have taken 3 queues. So you have to take 3 queues for implementing this one. So now let us look at the working. See, we will insert these elements in this priority queues. So every element is inserted in a priority queue depending on its priority. So A is having priority 1, so it will be inserted in Q1. Then B is having priority 1, so it will be inserted in Q1. C is 2, D is 3, E is 2, F is 1, then G is 2, H is 3, I and J are 2. So the elements I have inserted them based on the priority. If more elements are coming, I will be inserting them. Whenever I have to insert any element, I will check its priority and I will insert it. That's it. Let us look at delete. Whenever you want, you can delete. But whenever you are deleting, you must delete an element from highest priority queue. That is first Q1. So this element must be deleted. You cannot delete any other element. You must delete an element only from Q1. Only from Q1. And that too in FIFO fashion. So strictly FIFO you should follow. Next element I want to delete. So who is the next element? Q1. Q1 is not empty. There is an element. Delete that one. Suppose after J I got one more element whose priority is 1 only. Then it will come here only in Q1. Now again I want to delete. Okay. From Q1 deleted. I want to delete Q1 deleted. Now again delete. Q1 is empty. Then go for second priority, that is this one. Now start deleting the elements from this queue. Suppose after this again I have one element L whose priority 1, it comes here. Then again if I want to delete, I must delete this one. I must delete this one. So from this working I can say that deletion should be done always from highest priority queue, and if it is empty, go to the next priority. If that is also empty, then go to the next priority. That's all about priority queues. Now more on this one, that is starvation and all, that are the concepts of operating system. So if you want to study further, you can study it. And you have to implement this one as a student exercise. So write down the program which is having more than 1 queues, and each queue must have priority, and take the elements along with the priorities and insert them. So this is a student exercise. Now next, let us look at second method where every element is having its own priority. Now second method where the element itself is a priority. For example, I have set of elements 6, 8, 3, 10, so on. The element itself is a priority. So the element is numeric, number itself is the priority. So 6 is the priority of that element. And this element, second element, value is 8. So the priority is also 8. So it means there are unlimited priorities. Priority can be anything. And even the elements can have same priority also. Like I can have duplicate elements, 8, one more 8 I have, 8, one more 8 I have. So this is duplicate, same priority. So 2 elements with same priority. And which one is minimum priority, which one is maximum priority? So for that, I have set the rule here that smaller number, higher priority. If the number is small, then priority is higher. You can change this to other way also, like larger number, higher priority. So if a number is bigger or larger, then it is higher priority. So based on this one, which is of highest priority element? 2. Then second one is 3. The next one is 5. So like this, these are the highest priority elements. So go on. It means if you want the elements in the decreasing order of the priority, means first highest priority, then next highest priority, then you have to arrange the elements in increasing order, sorted order. Next, the question is how to implement this. Now this is not FIFO, this is not FIFO, right? So I have just taken an array. I have to store those elements in an array. So how I should store? So when we want to implement a priority queue using an array for these set of numbers, that is unlimited priorities, there is one known method. We will learn that in some other section. But here I am having two options or two suggestions. So let us see what those suggestions are. First one is, when I am inserting the elements, insert them in the same order as they are coming in. Like suppose insert 6, then 8, then 3 and so on. While deleting, find out the maximum priority element, search for that element and then delete that element. Then second method, insert in increasing order of the priority. So when the elements are coming in, don't insert them as it is. Try to arrange them in increasing order of the priority so that the last element is of highest priority. And when you are deleting, you can simply delete the last element. So the difference in these two methods is, while inserting, we are simply inserting it, but while deleting, we are finding out or searching for an element and deleting it. And here, while inserting, we are trying to properly arrange it. While deleting, we are simply deleting an element. So I will demonstrate how these methods works one by one. So first one I will take. Let us insert and delete few elements. Suppose I want to insert the element 6. Insert it. Next element at the last. Next element at the last. Next element at the last. So every time I am inserting an element at the last. So how much time it is taking for one element? Constant time. Like I want to insert 15. Okay, insert it here. This is the last element, right? The next I want to insert 2. Insert it here. So constant time. Then insert here 9. Right? So this is the recently last inserted element. So the time for insert is constant. Now I want to delete. Delete. So which element I can delete? I cannot delete any element that I like. I have to delete highest priority element only. Then only we say it's priority queue. So which is of highest priority? This 2 is of highest priority. As I said, smaller the number, higher the priority. So 2 is of highest priority. Then how do I know that is of minimum priority? Search for it. Search for it. So search and find out, then delete. So first search and then find out, then delete. Okay, after deleting this one, move 9 here because I have to shift the elements also. The next highest priority, search, which is minimum. This one, smaller number, higher priority. So delete this one. After deleting, also I have to shift the elements. So I have to do two things. Search, which takes order of n time, and shift I have to do for deletion. So that also takes order of n time. So total it is 2n. So we write it as order of n. So insertion takes constant time and deletion takes order of n time. So I was simply copying the elements and while deleting I was searching. Now I will show you second method, that is second suggestion. Now in the second suggestion I will insert those elements. Just watch how I am inserting. 6. Okay, 6, perfect. Then 8. See, 6 is smaller than 8. Move 6 here and insert 8. Move and insert. Then 3. Okay, 3 is smaller than 6, so insert it. 10. So 10 is greater than this one. Move 3. 6. 10 is greater than 8 also. Move it. Then insert 10 here. So I am inserting an element in the sorted order. Yes, and that is decreasing order. So insert an element in sorted order. So again 15 I want to insert. So move 3, move 6, move 8, move 10 and then insert 15. So this will shift all the elements. So how much time it is taking for insertion itself? It's order of n because I have to shift the elements. So searching I don't need and shifting. So shifting is taking order of n time. I have to shift because I have to insert it in the sorted order. Then how I will delete? Delete. So which is the smallest element right now, right presently? What is the smallest element? 3. So delete 3. So take out 3. That's all. So now the list is still here only. So how much time it is taking? Deletion. Constant time. So this has changed. See, this is taking n time and this is taking 1 time. So that's all. 2 suggestions I have given you. One suggestion was insert them as it is, while deleting you search. Second method, insert them in the sorted order, decreasing order of value, increasing order of priority. So that highest priority element is at the end. So that while deleting, we can simply delete it in constant time. So whichever method you follow, one of the operation is taking order of n time. The other operation is taking just constant time. So that's all. This is not the end of this priority queue. We will learn about the priority queue once again in some other section. Now our topic is implementation of a queue using 2 stacks. Actually, queue itself is a data structure. We can implement it using array or else using linked list. But if we have 2 stacks, we can make them work just like a queue. Let us see how it is possible. So here I have 2 stacks, stack 1 and stack 2. And here I have some set of elements that has to be actually inserted and deleted from a queue. Means NQ or DQ I have to do. But I have stacks. Now let us NQ and DQ some elements. First element 6, I want to NQ. So I should insert it in stack S1. Push it in S1. The next I want to NQ3. So push it in S1. I want to NQ9. Push it in S1. NQ5. So push it in S1. Now I want to delete. I have inserted 4 elements in a queue. Now I want to delete. So if I want to delete, I should get the element 6 as per FIFO. But these elements are in stack. If I delete any element, means pop out an element, I'll be getting 5. How to get 6? So transfer all these elements into stack 2. So first 5 will go here. Then pop out 9 and push it here. Pop out 3 and push it here. Pop out 6 and push it here. Now all these elements are transferred there. They are in stack 2. Now I can delete an element from stack 2. So what is the topmost element? 6. Yes, as per FIFO, I should get 6 first. So yes, 6 is deleted from the stack. So the element 6 is gone. Now next what I should do? You may be thinking I should transfer the elements back again to S1. No, we don't have to. We don't have to. That's what our common sense works, that we send there and popped out. Now send them back. No, no need. See, if at all I want to delete one more element, which element should be deleted as per queue? As per queue, the next element was 3. So 3 should be deleted. So where is 3? Topmost element in S2. So why to bring it here? Let it be there only. Will it work like this? Let us continue insertion and deletion of few more elements, NQ and DQ of few more elements. Next element I want to NQ. So the next element is 4. So this is 4. Next element I want to NQ, that is 2. So 2. So it means while NQing, I am just pushing an element in S1. Yes, push an element in S1. Now let us DQ. Delete one element. 3 will come out from the stack 2. Yes, delete from here. Delete one more element. So 9 will come out from stack 2. See, they are coming in the same order, 6, 3, 9. Yes, 6, 3, 9. Delete one more element. So 5 will come out from stack 2. Now I want to delete. Actually, which element should come out? 4. But stack 2 is empty. So what to do now? If stack 2 is empty, transfer the elements from S1 to S2. So pop out 2 and push it in S2. Pop out 4 and push it in S2. Now delete the element. So 4 will be deleted. Yes, it's working perfect. Now let us see how they are working. I will write down some functions or algorithms. I will not write complete executable function. Now let us see how NQ is done. Let us start once again. NQ first element 6. So push it in S1. NQ next element. Push it in S1. NQ next element. Push it in S1. So NQ means always push in S1. So NQ operation. So NQ means insert or just push an element in stack S1. This is what we are doing whenever we are NQing. Then whenever we are DQing, deleting an element, what we are doing? Let us see. Transfer all the elements here. So 9, 3, 6. Then delete the element. So 6 is gone. So we are transferring the elements and deleting from S2. Now again I want to delete. So don't transfer the elements. Directly delete from S2. Directly delete from S2. It means if S2 is having some elements, directly delete them. If S2 is not having any elements, transfer the elements from S1 to S2, then delete. So I will write down DQ function. So DQ function I am writing. See, the first thing in DQ what I should do is whether S2 is having some elements or not. Check it. If it is empty means transfer the elements from S1 to S2. So first check whether S2 is empty or not. If is empty S2, if S2 is empty, then what I should do? Transfer the elements from S1 to S2. See, I am checking S1 also here whether it is empty. If S1 is also empty and S2 is also empty, both are empty means Q is empty. So I will give a message that Q is empty. So here if S2 is empty, then check if S1 is also empty, then give a message Q empty and return X. So that X will be -1 means elements are not there, Q is empty. So that's why we return -1. Else, otherwise, if S1 is not empty, transfer all the elements from S1 to S2. So using a loop, I will transfer all the elements until stack 1 becomes empty. So I'll write down the code there. So here is the code while not is empty S1. Until S1 is not empty, pop out the values from S1 and push them into S2. So this transferring will be done. So after transferring, it will come out of else and outer if. Now return the element. So I am returning an element that is popped out from S2. Once again, I'll explain you. If S2 is empty, then transfer. If it is not empty, then it will directly return the element from S2. If S2 is empty, then it will enter into this if, otherwise directly it will pop out the element from S2. So we have to check whether Q is empty or not because we cannot delete if it is empty. But while pushing, I did not check whether the stack was full or not. So assume that these stacks are implemented using linked list. So that's how a queue can be implemented using two stacks. So it's a student exercise. You have to write down an application or a program for implementing queue using two stacks.